So class, we will continue on last topic, okay, chapter 3, which is universality of NAND and NOR gates. NAND and NOR gates can be used to construct other type of gates, which are AND or AND NOT. So these two gates known as universal gates. Next slide, I will show you how we can construct other type of gates which are not AND and OR gates using only NAND and NOR gate. So we start with the NAND gate. So how you can construct a NOT, okay, by using NAND gate. So if you refer to these equations, so this equation is actually representing NAND. You must remember NAND. What is the format of equation for NAND? So we assume we have two variables. For example, y equals to a b bar, right? So this is actually your NAND equation. So based on this equation, NAND must have at least two variables. For this example, a, b, and then of course you need to have sign dot, or you can just omit the sign dot, and the most important thing is actually the bar on top of the variables. So you must remember on your mind, NAND you need to have at least two variables, and then you have bar on top. So for this case, okay, for our first gate, which is NOT, how you are going to draw NOT by using NAND. Okay. And then at the same time, you must remember NOT equation. So NOT equation is y equals to a bar. Okay, if your variable is a, so you have a bar. Okay. So here you need to change NAND. Okay, sorry. Okay, you need to change NAND until you will get this NOT gate. So kalau NAND tu you have two variable, right? But for NOT you only has one variable. So macam mana kita nak buat lah that kind of things. Okay. So we assume that kita ada satu variable sajalah, which is a, or you can use any kind of variable b, c, d or any variable. Dalam case ni kita guna a. So kenapa dia buat macam tu? So we change y equals to a dot, okay, based on this format. Okay, you need to follow this format. A dot, okay, supposedly we need to have another kind of variable. Okay, so if your first variable is a, so maybe the second variable is b, c, d or other kind of variable. But in this case, kita tak nak guna other type of variable because your NOT kan ada satu je a, and so that's why kita dot dengan a juga. Okay, and then you put bar on top. Okay, so kenapa kita kata benda ni dia akan jadi NOT? Because when we prove, okay, so you need to prove. Betul tak bila kita prove benda ni dia akan dapat NOT. Okay, so how we are going to prove? So actually proving you can apply De Morgan lah. So this is just part of proving lah kan. So apply De Morgan, you will get a bar plus a bar, right? Bila you pecah ni kan. Okay, when you break the bar, so you will get a bar plus a bar, and then you simplify by using theorem. Okay, so a bar plus a bar, you will get a bar. Okay, so this means that when you draw these equations, okay, this equation, okay, and then when you simplify the last equation, you will get a bar. So it shows you that you need to draw this equation. Okay, so this equation is equivalent to NOT gate. So macam mana nak draw, you akan dapat macam ni lah. Kan? Sebab kalau yang biasa untuk NAND, kalau kita ada dua variable kan, biasa kalau kita ada dua, contohnya A dengan B, so kita akan lukis macam ni, betul tak? So you akan dapat A B bar. Tapi untuk case yang ni dia lain lah, yang ni kan. Yang ni kenapa kita A saja, sebab kita nak follow this equation. So A satu variable saja, none with A juga. So you akan dapat A bar. Right? So ni untuk yang pertama for not. So macam mana you nak represent not gate but using NAND to represent the equation, the equivalent to not, but the gate that we are using is NAND gate instead of not lah. Right? So second is AND gate. So how you are going to draw AND equation but using only NAND. So same with the previous one. So you must remember the format of NAND. Okay, and also the format of AND. So AND you must have at least two variables. So same goes with NAND. NAND also you must at least have two variables. So this is AND, A and B. Okay, but kalau kita draw A and B, dia tidak menggunakan sebarang NAND, right? So now kita nak guna NAND tu, tapi hasil dia sama seperti AND. Okay? So what you are going to do is actually you need to put double invert. Okay, you need to put double invert. Kenapa double? Because if you prove by using the algebra theorem, what happen when A double invert? So kita ada belajar sebelum ni kan? Okay, kalau you dapat A double invert, so what happen when A double invert? You will get A. So this is the theorems. A double invert is equal to A. So that's why when you have AB double invert, so you will have AB. So AB is N. Okay, it shows you that you need to draw this equation, okay, to represent N. So based on this equation, it shows you that you have two NAND. Okay, first NAND for the below bar or below invert, this one. This is for below invert. This is for below invert. Okay, this is for A B bar. And then you connect with another NAND. So this one is another NAND. So you already have A B bar. So when you connect to another NAND, that's why you will get AB double invert. Okay, so what means by AB double invert? This is actually equivalent to A and B, or this is actually equivalent to AND gate. So you get me? So this is how you draw AND gate but using NAND. And the last one, OR. So how you are going to draw OR gate by using NAND. So actually the method is similar with the previous one. You need to add bar, okay, on top of your equations, okay, because we want to draw equation by using NAND. So you kena ingatlah format NAND, dia kena ada bar juga kat, at least satu bar lah, okay, at least satu bar. So kalau kita draw basic OR, so this is a basic OR, which is the original OR lah, yang kita belajar masa chapter 2. So A plus B, this is OR kan. So kalau you tengok equation OR ni, dia tak ada bar pun kat atas. So bila tak ada bar, bila kita nak lukis, means that you tak boleh nak lukis guna NAND lah, because NAND dia memerlukan ada bar kan. So how you nak change this one ni, macam mana you nak ubah, okay, supaya dia ada bar on top. So that's why the step is actually similar for the previous one. So you need to add double invert. Okay, whenever you want to add invert, you need to add double, not single, not satu bar lah. So kenapa? Because we want to change the equation in form of another format. Maksudnya sekarang ni kita nak change equation OR kepada NAND. Tapi at the same time, whenever kita buat, kita tak nak mengubah yang asal dia. Maksud saya, kalaulah OR ni you letak satu bar saja, and then when you prove, you dapat balik tak A plus B? Tak dapat kan? So tapi kalau you letak A plus B double invert, when you put double invert dan A plus B double invert, apa berlaku bila you prove kan menggunakan teori algebra? You akan dapat A plus B balik. Betul tak? So this is the reason lah kenapa kita kena sentiasa tambah 2. Okay, 2. Okay, so this is the first step. When you insert double invert, okay, so you will get A plus B double invert. Tapi kalau ikut format double invert ni, dia still tak follow format NAND, because NAND dia tak boleh ada plus kan. So apa yang kita kena buat? So we need to apply De Morgan to the bottom inversion bar. So when you apply the bottom inversion bar, you akan dapat A bar dot B bar atas. Okay. So based on this equation, so actually you are already done for changing, okay, the OR equation, okay, become to the NAND equation. Okay, kenapa? Because now the last equation yang kita dah buat after we apply De Morgan tu, dia dah change sign plus to dot. Okay, at the same time dia pun dah follow equation untuk NAND kan, because equation untuk NAND, this one kan, NAND is A B bar, means that you have dot and then you have bar on top. So based on this equation, okay, based on this equation, so actually you already follow the NAND equation, because you have dot between these two variables and then you have bar on top. So now by drawing this equation, okay, by drawing this equation, so this equation is actually equivalent to A plus B. Okay, kenapa saya kata is equivalent to A plus B? So I will prove this equation ni. Saya akan prove sampai habis supaya last kali dia akan dapat A plus B. Okay, so this is the proving kan, proof. So I apply De Morgan sampai habis lah. So you akan dapat bila apply De Morgan, you will get A double invert. I pecah kat sini kan. Okay, plus with B double invert. So A double invert plus B double invert is actually equal to A plus B. You get it? Nampak tak? Maksudnya you draw benda ni, you draw yang ni, sorry. Okay, you draw yang ni, tapi sebenarnya dia mewakili gate OR. So this is actually this gate, okay, this circuit is actually equal to A plus B. The whole circuit, okay, this whole circuit is actually representing A plus B. Okay, so this is for the first part, how you are going to construct AND or NOT by using NAND. Okay. So next, NOR gate. So actually NOR and NAND is quite similar. The step is actually quite similar. Okay, the differences just only the sign. Okay, NAND you need to have dot and bar on top. For NOR, so you need to remind, okay, that NOR equation for NOR yang kita belajar masa chapter 2 is A plus B bar. Maksudnya whatever yang kamu buat, okay, when you want to change the equations, to make sure that it follows the NOR equation, so you must follow this format of NOR. Yeah, you need to have of course variable, berapa banyak variable tu depends lah. Okay, yang paling penting is actually the sign. You need to have plus and then you need to have bar on top. Okay. So we refer to the first one. Okay, how you are going to draw NOT by using NOR. So actually same with the NAND. Okay, you know that NOR you need to have plus. Okay, so this is how you draw OR gate by using NOR. Yeah. So y a plus. Okay, you need to have another kind of variable, but in this case because kita nak lukis not kan dia ada satu variable, so kita kena plus dengan diri dia jugalah. Kan? So this one you akan dapat a bar. Kenapa? So kita tengok, kita prove we prove this one, you will get a bar dot a bar. Means that I gunakan De Morgan lah untuk proving. So you will get a bar. So drawing these equations, by drawing this equation, so actually you representing these equations. So this is how you draw not by using NOR. Second is OR. How you are going to draw OR gate by using NOR. So same with the NAND and AND. Okay. So OR gate is A plus B. This is OR. Okay, this is OR. Okay, but for the original OR, dia memang ada plus je kan, dia tak ada bar. So macam mana kita nak buat? So we need to add bar lah on top. Okay, untuk tukar dia menjadi 0, tapi at the same time dia sebenarnya mewakili OR. Faham kan? Kita bila kita lukis circuit tu, kita lukis guna no, tapi hasilnya maksudnya y ni lah. Dia y ni, hasil dia akan dapat OR. Okay, dia sama seperti kalau you lukis OR lah. You lukis benda ni, okay, you lukis yang ni bila you run guna circuit maker tu kan. So dia sama juga bila you lukis this one, hasil dia akan sama. Hasil dia akan sama, maksudnya whatever input yang you masuk untuk A, B apa semua tu, dia akan sama lah dengan OR. Okay. So kalau you tengok kat sini, macam mana kita nak lukis OR menggunakan NOR. So you just insert double invert. You letakkan double invert. Kenapa? Sebab you kena ingatlah yang atas ni kan. Yang atas ni NOR kan dia kena ada invert, sekurang-kurangnya satu. Okay. Kita tak boleh letak satu je invert kat sini. Kenapa kita tak boleh letak satu? Sebab kalau lah contohnya saya letak satu je, y a plus b bar kan, mungkin ada tanya, Miss kalau kat atas ni kan dia satu je bar, kenapa untuk OR ni kita letak dua? Okay, because kalau kita letak satu, bila kita prove, you nak tahu benda yang you buat tu betul ke tak, when you prove means that when you apply the De Morgan to the bar tu kan. So proving ni dengan cara you pecah bar lah, you dapat tak balik a plus b. Kalau you tak dapat tu maksudnya salah lah, maksudnya bilangan bar you tu mungkin tak cukup lah. So contoh dalam kes ni kan, you akan dapat apa ni? Bila pecah bar, you akan dapat a bar dot b bar. Ini hasil dia. Sedangkan yang kita nak adalah a plus b. Nampak? Sebab tu kita tak boleh letak satu bar. Yang ni yang ni kira salah lah, tak boleh letak satu bar kan? So kita kena letak dua bar. Bila kita letak dua bar, kita prove dengan cara apa? So kita kan ada satu teorem kan, algebra, double invert. So you akan dapat balik benda yang sama kan. So kita buktilah. So maksudnya bila you lukis benda ni, you lukis equation ni, okay ni, okay, dia sebenarnya sama dengan OR. Okay. Okay, next we will draw AND, but using only NOR gate. Okay, first you must remember the AND equations. So this is your AND equations. Sorry. So this is your AND equations. Okay, A and B. So based on the equation, we need to change a little bit the equation to make sure that the equation must in form of NOR. Okay, so for NOR equations, this is the NOR equations. Y equals to A plus B bar. So you have to make sure that you have sign plus, okay, plus sign and also bar, okay, on top of your variables. Okay, so this is the step. Okay, I draw here. Okay, I write here. Okay, y equal to a and b. So this is your n. Okay, so how we are going to change the equation? to form to NOR, same as previous example. So actually you need to add bar on top of your variable. So in this case you need to add double invert. Okay, because when we prove the equation, you still can get the original one lah. Okay, maksudnya you akan dapat balik A and B. Okay. And then next step, so you need to apply De Morgan to the bottom inversion bar. Why? Because we need to change your signs. Okay, your sign is dot, so we need to change to plus sign. So when we apply De Morgan to the bottom bar, so you will get A bar plus E bar, and then you remain your top inversion bar. Okay, so this is the step. So based on the last step, so now your equation is actually fully transformed to NOR equations, okay, or NOR format. Okay, NOR format, because you already changed your sign dot to plus, and you also have a bar on top of your variable. So this is actually how you can draw AND, okay, by using only non-gate. Okay, so you need to draw these equations. Okay, so you will get this one. Okay, means that this whole circuit will be presenting AND, which is A and B. Okay, so this one is actually representing A and B. Means that if you draw this circuit, okay, and also A and B, and then you run the circuit, so you will get the same answer. Okay, so this is how you can draw how you can draw all three basic gates by using NOR gate. Okay.